Hello everyone and welcome back to another Fusion 360 live stream. Today we are going to be making something special for Mother's Day. I'm Jason Lichtman and with me, although you don't see him, is CJ Abraham. Would you like to say hello, CJ?
Hello, everyone. Yep, as Jason said, I'm CJ Abraham, and I'm a product manager on the Fusion manufacturing team.
Excellent. And together we are going to try to make the mothers in our lives super proud. We have Tyler Kirkera on the keyboard, and as I mentioned, we are going to be making a Mother's Day gift. Well, the first question you're probably asking yourself is, what are we going to be making? And I'll show you. You probably saw this in the thumbnail. This is a cow planter, a wooden planter. You can see from above that you can put your flowers in there with the soil, with the drainage holes, and this is going to be able to house your flowers or anything else you'd like to store in it. And you're probably wondering, how on earth did I pick this as the project for the day? Well, let me tell you. This particular cow I made when I was 12 years old. I was in a summer camp kind of thing, and we made this using a scroll saw based on patterns. So you tape the paper pattern to your pieces of wood, you cut it out with your scroll saw, you use a router to route the edges, you put it all together, you bring it home from camp, and you make your mother proud. And so today, we're going to go and make or recreate the same exact project using Fusion 360 with a little bit more flavor to it, right? Because now we have some CAD that we can use to make this a little bit more detailed. We can also use fancy tools like CNC machines to actually route this. And that's where CJ comes in. So I'm going to go and design the actual cow with you today. And CJ, are you up for making it?
Yep, I'll be putting some toolpaths on here and show you guys how you can make it.
Perfect. So let's go and take a look on the screen for a moment at what we're actually making. You saw it in person. This is going to be the digital representation of that same exact part. We're going to make all of these individual components themselves, including the mouth, the face, and the tail. And then CJ is going to go and actually go and make our toolpaths for it. Sound fun, CJ?
Indeed, it does.
All right, good. So let's start with a new file. We're going to start from scratch. So we're going to go and start with a blank slate, so to speak. And what I want to be able to start with is I want something for reference, right? You guys already saw that I had the actual cow in my hands. And so I want something to be able to help me design this a little better. Now, back in the day, I had those paper plans that I was able to tape to the wood. In Fusion, we can use something similar. It's called a canvas. And you can use a scanned image from a flatbed scanner, and you could even use a picture from your phone. So I have a couple of pictures of this particular planter that I took, and we're going to bring those in using Insert Canvas. I'm going to choose the canvas for my computer itself, and we're going to start with a front view. I'm going to pick the front plane. We're going to go and give myself a nice little zoom in here, and it looks pretty good. Now I want to make sure that this is going to be made the right size. So let's go and measure our actual planter. And the goal here is to use something called calibrate in Fusion, where you pick 2 points on the design and it'll calibrate the image based on those 2 points and the measurement in between. So I'm going to go and grab, let's say this planter here. Let's go and zoom in so you can see this. I'm going to measure from the left to the right side of the legs, and it looks like it's going to be 7¼ inches. And I know that this isn't the most accurate measuring device out there, but it's going to be more than good enough for our purposes today. And so let's go and calibrate this image. I go into my Canvas folder here. I can right click and choose Calibrate. I could pick this corner of the leg and this corner right over here of the leg. You'll notice that I'm in metric right now because my default units are metric. I'm a metric kind of guy. But I can type in 7.25 IN for inch and hit enter, and it automatically knows the right scale. So now we can go and zoom out, and this image is actually already the right size. I also, and this is my personal preference here, I like to turn on the origin and I like to move the canvas until it lines up with something that I think is reasonable. For this particular design, I think that the center left to right makes sense. And I also think that the bottom, like the legs, makes sense so that when I have my final assembly, I could go and place this wherever I want and it would automatically sit on, let's say, the table, if I want to do a rendering as an example. So this is looking pretty good, and that's good enough. I'm going to go and say OK. Now I also want to bring in the rear view at the same time because I have the feeling that the front and the back are really the same part or really close to each other. So I'm going to do the same thing again, insert canvas, choose the rear view, choose the same plane in this case, and I'm going to go and scale this image up a little bit more manually, and then I'll zoom in a little bit and we're going to do the same thing. So we're going to calibrate from, let's say, here to here. That's going to be 7¼ inches. Now I don't want to keep typing in IN for inch over and over again. So let's also go to our document settings and change this from millimeter over to inch. There we are. And then let's go and also move this canvas. And we're going to try to line this up with the other canvas. And you'll notice, by the way, that we have these canvas opacity options. So you can make this super opaque and then you won't be able to see anything through it. You can make it super transparent and then you're not even going to see the actual canvas. So somewhere in the middle is probably a good start. And then we're going to go and move this until it lines up roughly with the one that's already there. And I'm happy with it. That actually looks pretty good. Cool. Now we're going to stick with the front view for now, but having the rear view is going to be very helpful, and you'll see why in a few minutes. Now I have a lot of different parts that we're going to be making. I could design these as bodies and turn them into components later, but CJ, do you think we should just make components from the start?
I do like to have them as different components for layout purposes, but either way.
All right, so let's use CJ's approach. I'm going to go right into create and say let's make new components here. And the very first component, let's call that the front. And normally this activate button is selected by default. I actually going to unselect it because all I really care about at this point is we're going to make a component for each of those different parts. And so I don't actually need to start designing the actual component. That's what I would want the activate button to help me with. So we'll go and say OK. We're going to go and do the same thing again, create another new component. This one might be the back. Now here's a keyboard shortcut for you. Well, not really a keyboard shortcut, more like a mouse gesture shortcut. If you right click, you'll see all of these different commands pop up. You'll notice that the very top command is repeat new component. So if you right click and then you move your mouse just slightly up and you click this, it'll go into your last command. In my case, the new component command. So let's go and add another one. This is going to be the face. And let's do that again. Right click, repeat new command. This one's going to be the nose. Actually, it's kind of like the nose slash mouth, I guess. And we'll go and say OK. Here's another mouse gesture shortcut. Just like you can right click and move your button here, you'll notice there are these little blue kind of pizza pies that are showing you where you're actually hovering. You can do another trick. If you right click and just drag straight up, it'll automatically do what we showed you earlier. So it's the same as right clicking, moving your mouse and selecting. So right click and just drag straight up is way faster. So we have, let's say, the tail we're going to add. We're also going to go and add kind of the center components. So we're going to call this a bottom, and then we're going to also go and make a side. And I think that's everything. Did I miss anything, CJ? I think that's all of them.
Yeah, that looks good to me.
Cool. So now I have all those components. Now, one of the things to know about making components from the beginning is that components can actually move in space. So if you don't want them to move, you are going to want to go and apply joints. You can go to Assemble and apply a regular joint, or it's just called joint, of course, an as-built joint, which means the joint is already, like the component's already in the right place. You don't actually have to move it anywhere. But if you want to simplify your life, in this case, I want all of these components to like move together as one. They're not going to move. I can just go and make a rigid group. And that's just saying that anything that I put in this group is going to work rigidly. They're going to move together. So let's actually go and do that. I'm going to say rigid group, the front, the back, the face, the nose and mouth, the tail, the bottom, and the side. And if I just hit OK, they're going to move together, but they're still going to actually be able to move. So the trick that you should know is that this thing at the very top here that right now says unsaved and is reminding me that I should actually save this design right away, this is what's called the root level. And the way Fusion 360 treats this root level is that it's as though it's its own component. And that sounds kind of crazy at first, but this allows you to be able to say, I want to make a rigid group between all those components that I've been making manually plus this root level. And now it's like saying that those are all going to be locked in relative to the assembly itself. They're not going to move at all. And now I can just go and say, okay, cool. So let's go and start designing our components. And I'm going to start designing, I think, probably the more artistic stuff first, and then we'll get to the center area, which is a little bit more geometric. So let's go and pick a component. So I'm going to go and start designing the front, and this little white dot on the side is going to help me activate the component. And the reason that you should at least consider activating components is that it's going to basically assign anything that I do right now to specifically tie to this component in particular. So when I activate a component at the bottom here, it's going to filter your timeline specifically to whatever is related to that component alone. If I go to the root level, I can activate that, and it's going to show me everything that I've done in total, including anything that you've done for individual components. But you can filter what you see in the timeline based on activating those components. So I'll go and activate this front component. I can still see my canvas, of course, and we're going to go and create the basic shape. I like to start with the basics. So we're going to go and draw a quick line on this front sketch. And I'm going to go and just draw a horizontal line like so. I'm also going to go and make sure that that line intersects with my origin so that this is truly going to be like the origin setting up on the very bottom of this part. So let's go and do that. I use coincident, the line, the origin, and it turns black. It's nice and fully defined. Good. Now let's go and also do kind of more of the basic shapes here for like the center area, in between the legs, so to speak here. I'm going to look at that and I think to myself, this would be a good use for an arc. So I'll go and create a quick arc and zoom in and try to get that as accurate as I can. I'll also make an arc from here to, let's say, around there. That's looking pretty good. I'll do the same thing here. That's looking pretty good as well. Maybe even also another arc from here to there. And that's looking pretty good. And I'll do the same thing here. Now, where it gets a little interesting for this bottom area is, we're going to be cutting these parts with it being flat, Z from this direction. But I notice that I have this kind of like arc thing where it doesn't really meet the bottom the way I would expect. What I want is like a proper vertical right there. So what I could always do is I can make construction geometry, like lines. So I'm going to go and make a line, and I'm going to go and draw a vertical line here. And I can select that line and also this arc, and I can make them tangent to each other. Let's actually do that in the reverse order. And now you see this constraint here for this arc. I can still go and move this point. Hold on a second. I think my selection filters might be a little funny. They are. If you're ever trying to select something and it's not letting you select it, the first thing you should check is the selection filters. This is the culprit. So I have it right now set to bodies, which means I can select bodies, but I cannot select anything else. That would be problematic. So let's go and turn that back on. And now, oh, this is way better. Now I could go and move this arc wherever I'd like. You'll probably notice that there's supposed to be a fillet here, so we'll go and add a fillet as well, and I could go and change this until I'm happy with that dimension. And, CJ, I guess this is a good time to ask you, what is the smallest size end mill that you're going to be using to cut this? Because I don't want to make my radius any smaller than that.
Well, to cut the outside profiles, I'd like to use a 1/4 inch up cutting end mill
Okay,
router bit. So anything that is at least an eighth of an inch radius for the fillets,
that would be
preferably
great.
bigger. So let's start with at least 200 thou.
Cool. We're nowhere close to that right now, so this is actually looking great, but I'll keep that in mind for later on. We're also going to go and add our fillet right over here as well. That looks pretty good. And then at the bottom, I'm going to go and do the same trick here. So I'll go and add a vertical line. I'll make these two tangent, and I'll fix any kind of geometry changes that happen that I'm not happy with. So actually, let's go and make this a little bigger. 0.5, oh, that looks great. And I'll go and make 0.5. Now, you all might notice that what I'm doing here is not exactly symmetrical, right? I'm kind of moving things kind of one off, so to speak. And in this particular project, not being symmetrical makes it a little bit more real, right? Like how my left hand and my right hand aren't probably the right size, they're not the same size. My right foot and my left foot, definitely not the same size. So why would the cow be any different? If I want this to be truly symmetrical, I can just go and draw a center line and use my symmetry tools or my symmetry constraint. But for something artistic like this, not having symmetry might actually be better. But keep in mind, CJ, when you're going to design the toolpathing for this part, that the flip of the part might not actually be acceptable, right? Because if you flip the part over, it might actually not line up right. Is that okay, CJ?
Yeah, we could figure out ways around that.
Good. Okay, cool. So let's keep going and we'll speed this part up a little bit. I have a much different shape over here for the outside. So for this, I'm probably going to go and use a spline. And a spline is a great tool to be able to create complex shapes. One thing to know about splines, if you don't already know this, is that the fewer spline points you use, the better. The more of them you put, the more complex the math gets, and you could end up with like waviness in the spline that you probably didn't expect. Now, generally speaking, I try to keep my splines to an end point, a start point, and one spline point in the middle. That's not a lot. For this particular example, I'm going to break my normal rule and we are going to put quite a few spline points. So I'm going to start at the very bottom here and I'm going to go and pick a point right over here. By the way, I'm noticing that I'm snapping to vertical right now and I don't exactly want that. So if you hold Control on your keyboard or Command on a Mac, that'll prevent us from snapping your geometry. So I'm going to go in here and I'm holding Control the whole time. And actually, this is a great point to make. I can't really see what this shape should be because the face is kind of blocking the way. So maybe I'm going to go and hit Escape and hide that. I'll show the rear view instead of the front view. Right? After all, they're going to be similar. And now let's go and use the rear view to go and make the same spline. Let's try that again. So again, holding my control point, I'm picking all my points. I am very much breaking my normal rule about number of spline points.
Rules were made to be broken, Jason.
Well, thank you, CJ. I appreciate that. The key really is knowing what the rules are to know what the problems are that are caused by breaking those rules and being okay with those problems when they come up later, right? So in this case, I have quite a few points. I have a little bit of bumpiness on the top, but actually that kind of gives this cow a little bit more character. So I'm pretty happy with that. And I'm not even matching the original picture very much, and I'm also okay with that. Remember, this is supposed to be a recreation, not a duplication. So I can have a little bit of a difference here, and that's okay too. The same trick I could go and apply here to the spline as well. So I'll go and make a vertical line here. I'll go and make these tangent, and that's looking much better over there. I'll go and do the same thing over here and make those tangent as well. Oh, they're already tangent. I don't even have to do anything. Perfect. I love it when Fusion 360 predicts what I actually want. Now keep in mind, by the way, that I left these lines at the bottom here as standard lines. I didn't make them construction. In this particular case, it's not really going to affect me negatively. But if I had geometry going across this region, like something like that, and I have these zones here that I don't want to actually be there, well, what you could do is you could just take those lines that I just made and you can make them all construction. I'm just using the keyboard shortcut X to switch them to construction geometry. You'll also see the button right over there on the right-hand side. This is looking great. I think I might have been causing a problem here though, CJ. Are you going to be able to cut out these sharp corners here?
Those ones I will not be able to. However, whatever tool that I use in there, those tool paths will automatically put in a radius. You're welcome to put a radius in, but if you don't, it'll be fixed.
Okay. Kind of leaning both ways. I think adding the fillet yourself is a good way to go because you know exactly what you're going to get. At some point during the cam process, you might end up changing the cutter you're using, and that would affect my result, right?
Yes, it would.
So yeah, so let's go and put in our own fillet. I'm going to go under the fillet tool. We'll go and add a fillet. That's way too big. Let's go and bring that down. And I think we do want the sharper. What was the minimum you said? 0.2?
Minimum is going to be 200 thousandths. Yep.
Let's go with that. 0.2, 200 thousandths. And I'll also add this corner too, and it goes and applies the same number. That looks great. Perfect. Let's go and finish that out. So now I have the basic shape for the front and the back. And if I want to, I could just go and start actually making this. So let's go and do that. I'm going to go and grab this profile and I'm going to go to create, extrude, and we're going to extrude this. Now I could extrude this going backwards or forwards, and it's really just kind of my preference. So I'm going to think to myself, which one makes the most sense? Well, I made the origin at the bottom of the feet, and I made it centered left to right, or at least approximately. And I could make this going forward relative to the origin or the back. My gut says I'm going to go forward. And the reason is because when I start doing the length of like the flower pot area where the soil is going to go, I think I'll have a little bit more control over how long it's going to go and the visuals and everything else. I think this makes more sense for me. Now for the thickness, I guess I should ask the guy who's actually going to make this. What material are you going to make this out of, CJ?
Well, I'm just thinking we would use 1 inch thick material. So as long as you make it some number smaller than 1 inch, that'll be okay. I'd like to leave space on the bottom and top to face off and hold tabs on the bottom. So
Hmm.
um,
Three
let's
quarter?
do 875. How's that
875 it
sound?
is. All right, so 0.875. That's looking really good. Now, I'm going to have to type in that value again and again and again, right? Because I'm using that same material for all the parts. Is that right, CJ?
Yes.
Okay, so although I could type in that value over and over again, there's a trick that I think that people would probably like to know about. CJ, any guess what I'm talking about?
Parameters.
Nice. So you can go and find that under Modify, Change Parameters. If you didn't know where to find it, you could also search at any time. So S for search on my keyboard, I start typing in parameters, and there it is, change parameters. So let's go and make a new one. This one will be called thickness, and the thickness here is going to be 0.875, and so now we can just use that value from now on. While I'm here, any other values, CJ, that you think might make sense to put in?
Well, for this particular one, that's
If you
up
have
to
no
you,
idea,
really.
that's okay.
Yeah.
So I'm thinking to myself, maybe the length of the flower pot area. Maybe I want to make multiple sizes of this, right? So let's actually go and say, flower pot area length, something like that. Really, I could just call this length and that would be fine too. And I'm going to go with 10 inches for now, and we could change that later. Now, we did talk quite a bit about the minimum radius, so let's go and put that minimum radius in here too, because I could always, if I wanted like a really small radius, I could just type in this value and use this. And I don't have
True.
to
Yeah.
ask you again what that value was. Anything else I'm going to put in? Oh, I know. We're going to end up engraving some of the face. So I want to have an engraving depth in here as well. So let's say engraving depth. And from your experience, CJ, is there a good depth that's like, not too deep, that's going to take too much machining time, but deep enough that I'll see it nice and clearly?
Anything between 50 and 100, that would be fine. So let's do 80 thousandths.
80 thousandths it is. Cool. That's good enough for now. I could always come back in here and access that later. So let's go and edit this feature, this extrude feature that we've already made, and let's change this value from 0.875 to the thickness value that we just put in there. So thickness. The result is exactly the same number, but now this number is tied to that parameter table. So if I change it in the parameter table from 0.875 to 3 inches thick, just to exaggerate, you'll see that my model changes instantly. Perfect. Let's go back. That looks good. So now I have this front face, the front part of my design. That looks really good. Let's go and maybe let's start to design the rest of it, actually. So let's go back to, let's say, the assembly level or the root level. Oh, another reminder, I haven't saved my design yet. Tisk tisk Jason. Let's go and save this design, and we're going to call this cow planter. And for live stream. Perfect. So now I have my file saved, and for the record, now the autosave is going to help me. Autosave, by the way, is set to every 5 minutes by default, but if you ever want to change that, you could just go under your preferences, And under your general preferences, you're going to see that there's an autosave option, and you could change it to any amount you want. So in this case, recovery time interval is set to 5 minutes. If I want, I can make this 1 minute, right? And it'll save in the background every 1 minute. So I have my overall design, but let's go and start to design like the shape of the planter and then the face and the tail and everything else. We have a whole lot to do, so we're actually going to speed this up a little bit. So let's go and grab our front view here. We'll create a sketch on what looks like the XY plane. We're going to start to design the face itself and the planter area. Which one do you want to do first, CJ?
Hmm. How about the planter area?
All right, so let's do that. So we're going to leave this canvas that we already have here, and we're going to go and design how we want it to fit. This is going to be like the side wall. This is going to be the bottom. I intentionally drew them kind of off center and like totally in the wrong space, but we can go and move those. Now we already know that the thickness is going to be the thickness value. Oh, wrong one. Let's try that again. From here to here is going to be thickness. That looks pretty good. From here to here is going to be thickness as well. That looks good. But now I have some choices. Do I want the side to be on top of the bottom? Do I want the bottom to be inside the side? All these are good choices. For my purposes, I think I'm going to make the sides to be like super kind of tall, and I'm going to have the inside butt up against it on the, sorry, I'm going to have the bottom butt up against it on the inside so that my visual on the side is going to look better. I think that makes sense. So
It
this
does make
is
sense. Yeah.
yeah, this is looking pretty good. I could also go and draw the other side, but another trick is I could just go and draw a center line like so, and we can go and take this one and just say, let's mirror it across. Now keep in mind that I don't actually need to do this at all because we're going to mirror the component later. We don't have to mirror the sketch. If anything, I tell people that whenever you have the opportunity to mirror a component or mirror a body or mirror a feature, you end up with a much better result because even though the result is actually the same, the compute time in the background changes. CJ, have you ever experienced that yourself?
For the compute time, yeah.
Yeah, if you make a lot of mirror commands and things like that in your sketch or patterning in your sketch, that does take quite a bit of compute time. So I'm showing you this quick visual, but you don't really need this here at all. I might want to go and put in some dimensions that matter to me, right? So what's the width of this interior area? I want at least 3 inches. If not, I probably want way more than that, maybe 4.5. But I'm starting to encroach on some dimensions here that might be a problem. So let me ask you this. CJ, would it be okay if we actually went down a little bit in our thickness? Like maybe three
Yeah,
quarters?
totally. Yeah, 3/4 is perfect.
Perfect. So let's go and change our parameter. It's going to go and change everything, including the sketch, and that's looking much better. That actually looks great. And this is pretty good. Let's go and leave that. So I'm happy with the flower pot area, or at least the sketch for it. The other thing I want to go and do is I want to make the sketch for the face. Oh, and by the way, we should rename this. So this is going to be flower pot area. Perfect. Let's go and make a sketch for the face itself. We'll go and create another sketch. This is again going to be a little bit more artistic. I definitely want the front view for this. And for this, I'm also going to go, and maybe I do want symmetry. You know, I didn't have symmetry on the body. Maybe I do want symmetry on the face. We all, after all, we all wish we had a perfectly symmetrical face, don't we? So we're going to go and draw a center line, roughly like that. I also am going to go and draw a vertical line here so I know roughly the angle for that center line. And I could even go and put in a dimension between them. And so it looks like we're at like 12 point something. Let's go with like 15 degrees and see if that actually would work. Nice. I like nice whole numbers. That looks pretty good. Now let's go and start to design this. I'm going to start with some arcs. So something like this. That looks pretty good. We're going to go with something like that. Maybe a little too hard. No, that looks great. We'll do another arc from here to here. That looks great. This is going to be a little interesting. I want to skip that for a second. And we're going to go, let's do the face right over here. That's looking, whoa. I don't know about that one. That looks a little weird. Let's try something else. Let's try a slot. And as of, I think it was a year ago, we added the the slot that has the 3-point arc to it, which I really like. So let's go and do that. We're going to go and draw maybe from here to, let's say, around here. And now we have a nice curved slot. Actually looks great. I'm pretty happy with that. I can add some symmetry right now and add that symmetry. Move this in and change the diameter a little bit until I'm pretty happy with it. And I don't know if I'm exactly happy with this just yet, but that's pretty good. I can also go and change the radius value. So right now we're at like 2.5. Let's see what happens if I've made that 5. Now sometimes when you change values, it'll actually jump your like geometry. So you could always just go and move it back, and you could also use constraints to be able to keep that where you want it. So this is actually overall looking really good. I'm pretty happy with that. I'll also go and add an arc from around here to here. That also is looking pretty good. And then for this ear, I'm thinking an ellipse. I think ellipse would work really well. Let's actually go and try that. So we'll go and draw an ellipse from, let's say, here to here and see what we have. Oh, I drew it in the wrong spot. That's okay. We can just go and drag this over and move this until I'm happy with that. I could also change the width and diameter and everything else until I'm happy, but I do want to go and fix these areas. I want them to be coincident. So I'll go and grab that and make that coincident. And that is looking overall pretty good. You know, my sizing's a little different. I can spend as much time as I want until I'm really happy with this design. CJ, what do you think so far?
I think that looks great. We're gonna have to
Excellent.
add some fillets in there, but we'll get to that.
Exactly right. So let's go and hide the front here. Actually, that was kind of in my way this whole time. This is looking really good. Now, what I want to make sure is that I have a closed profile. So if I hide the canvas for a second, you'll see here, every time I have a closed profile, it highlights in blue, and the outside, the contour highlights in black. I'm noticing something funny is going on here. I somehow added an extra line that I didn't intend to. So I'll go and delete that. And also, I'll go and extend that line. So let's go and do that too. Under Modify, we'll go and extend this. That looks pretty good. So this is a closed profile, but over here, this doesn't appear to be closed. This ellipse appears to be closed, and I have some sort of opening. Now, what you're going to look for here are white dots. The white dots tell you that you might have something you should look at. In this case, if I zoom in, I didn't close this area right there. So let's go and turn on our canvas again, and I can just go and drag this. It'll snap on there. And now when I go and I hover over this area, it's actually looking much better, fully closed. Only things I think I have left, I might want to go and put in some geometry for some of those other details. So maybe I'm going to go and add a couple more arcs. Maybe from this corner to here, that's looking good. From here to here, that's looking pretty good. From there to there, also looking pretty good. And I keep doing this until I'm happy with my shape. Again, how much time you spend on this is entirely up to you and what you're happy with. So this is overall looking really good. Go from there to, let's say, here. That's looking great. Looks like I have a flat spot, so I'll go and grab a line from there to here. That looks nice. And then maybe that's also a straight line too. No, that can't be. That's probably an arc as well. We'll go from there to there until I'm super happy with it. That's looking great. Cool. Now I do also want to add the eyes. Let's go and add some more ellipses, I think would be a perfect use here. So let's go with ellipse. Oh, and ellipse apparently draws from the center. So let's actually go and escape that and we'll try that one more time. From the center, going up roughly there, and then I'll drag it out, and that's looking pretty good. I'll drag this down a little bit, maybe add a circle for the eye, and then also maybe an arc from here to here for the eyelids. It's actually looking really good. I'm pretty happy with that. Let's pay our attention to the mouth area. Let's do the same thing. I think the curved slot is a good choice. So let's go and use the 3-point arc slot. I'll go from here to here and give it a nice curvature. That's looking pretty good. I'll do the same thing from, let's say, here to here. That looks great. And then also from here to here. Perfect. Now, you guys out there will probably notice that some of the things that I designed, I did only in half, and some of them actually cross the center line. And it's really just a question of preference on how you draw it. So even this mouth that's actually crossing the center line, I'm actually only going to engrave this right half, and then we're going to end up mirroring it across. So anything that's here, I could trim out or I could leave. It just doesn't matter. You get to pick. I will go and trim out this area so that that's nice and clean, and that's overall looking really good. All right, cool. I'm happy with that. Anything I miss, CJ?
Nope.
Oh,
Well, these smaller radius on here,
hmm, the one right
I'm
here,
going to use a
probably?
smaller tool to do all of the engraving. So don't worry about the quarter-inch tool I was using before. I'll use something much smaller for those.
Oh, perfect. All right, good. That's helpful. All right, so let's go and draw maybe this area as well, and I think we'll be ready to go and actually model this up. So I have something like that. We'll go and add our arc as well. Pretty good. Oh, I want these to be tangent. Let's go and make that tangent as well. And I'll clean up this geometry until I'm pretty happy with it. And if I'm not happy with the arc because it doesn't seem like it's actually the right shape, I could just go and delete that as well. And I could go and use my spline. It's like a really great tool to be able to make shapes like this, especially when you know how to use the spline tool. There you are. And I can go and move this and make this any shape I want. That's actually pretty good. I think the only thing else I missed is the eyebrows. Let's go and do that too. So we'll go back to arc. Nope, we'll go to slot rather, and we'll do the 3-point slot. And I'll go and pick from here to here, and there we are. All right, good. Now I think the rest is actually going to come together really fast. So I did the hard work, except for the tail. We skipped the tail so far. We're going to go and take this and turn it into 3D. So let's go and let's work with the bottom piece. I'll go and activate that component. I'll go and grab the sketch that we created for the shape. This one here is actually the face, and it looks like I might have put this in the wrong spot. Nope, that one's in the right spot. Flower pot area, that's the one we wanted. Okay, so we're going to go and select this surface, or rather this profile. We're going to go and extrude that. I'm going to drag this back, and for the distance, we're going to go and use that value that we picked, so length, and that looks pretty good. Now we'll go and take the side, and we're going to go and take that same profile. Let's go and grab this side right over here, and we'll go and extrude that. We'll also go and make this the same length based on that parameter table. That's looking pretty good. And we are going to want another one of those on the other side as well, right? So let's go and right off the bat, let's go and make this, make a copy for the other side. So I'll go and select this side piece, Control C on my keyboard because I'm using a PC, Control V. You will automatically get the ability to move this right off the bat. If you'd like to, you can, you don't have to. I'll go and hide the original side, and I'm going to go and apply a joint. I'm going to pick this inside surface, and I'm holding control so that I only select points that are on this inside surface. And I'm going to go and pick this bottom middle. And then using this, which is the middle piece or the bottom, I'm going to go and pick the middle on the bottom as well. And it's going to go and place it in the right spot. Almost. I'll just do a quick flip. And it turns out, no, I don't think the flip is the right move in this case. I think it's going to be the flip and change the angle 180 degrees. There we go. And now I have two different components for the side. They're really the same component. That's looking good. Now we also had the front that we've already made, so it's starting to come together. Let's go and make the face area. So I'll turn on the sketch. I'll go and activate the face component, right? I'm actually going to go and hide the front component for a moment because the sketch is a little bit behind it. It'll be easier to select. We're going to go and select all of these profiles that I want the face to have, just like this. Perfect. Now, some people say that less is more in your sketches, and I often say that too, actually. So maybe I should have made the face as a separate sketch, like the details of the face as a separate sketch. It would make this easier for me to select. But I selected everything. I'm going to go and say extrude, but I don't want to extrude from where we are because that would actually go right through this front piece. Instead, we'll change the profile plane from I'm saying that all wrong. We're going to change where we're starting from profile plane to from an object, and I'll just pick the front of this component as where we're starting, and then it'll go and show up in the right place. For the thickness, we'll go and type in thickness. That's looking pretty good. We'll also do the same thing for the mouth and nose region. So let's go and hide the face itself, hide the front. We'll show that sketch again. So we'll go and show that sketch. And we'll go and grab this region right here, including those details, and I'll go and extrude those as well. This time I'll show the face. Oh, I got to stop myself right there. I actually still had the face activated instead of the nose. Now this isn't that big of a problem, but keep in mind that if you want the ability to filter, you have to set this up correctly. You have to choose to activate the right component when you need to. So let's actually go and cancel that for a second. Let's choose the nose or mouth region and select this again. Now when I go and I create this, the extrude feature will be part of the correct component. Not that big of a deal if you get it wrong, but I think if you can get it right, that would be better. We're going to do the same thing and choose the very front here. And for the distance, we'll go with thickness. That looks really good. Cool. CJ, how are we doing so far? You guys don't hear him, but he's saying, yeah, I'm doing great. I'm sure. Thumbs up. All right,
Yeah,
so
sorry, I had my mic muted.
it's all good.
Yeah,
Any
it's all looking
questions
good.
so
I'm excited
far
to put
for
some toolpaths on it.
when we're gonna manufacture it? I take that as a no. Okay, so this is looking great. Let's go and put in those details. Now remember, I told you that we were going to mirror everything over. Could I mirror it now? Yes. But if I mirror it now, I'm going to have to repeat my work later for the details. So why don't I just put the details in the half and then we'll mirror it across. Let's go and do that. I'm going to go and activate the face again. We'll go and show that face sketch. We'll hide some components that maybe don't matter in this case. And let's go and select those details, right? So let's go and also hide those too. So we're going to go and grab, let's say, this region right here. Actually, maybe the eyes. So we'll go and select this eye region like that. And we're going to go and extrude this, but we want to do an extrude cut from the front surface. So I'm going to say grab that front surface and go in. And the depth that we're going to use is the depth that we chose, engraving depth. That looks pretty darn good. I like that. Let's show that sketch again, and let's do another detail actually. Let's make the eyelid pop out. So we're going to go and make an extrude. This time we're going to start at that surface. Oh, I think I might have misselected. Let's try that again. We're going to start at this surface, and we're going to go forward, and we're going to go like 50 thousandths difference. Oh, hold on, too many decimal places. There we are. That's looking pretty good. Let's also go and do the same thing with the rest of the face. Let's actually go and zoom in over here. And I could also just go to the other side as well. And we're going to do an extrude. This time we're going to go and do it from the very front, and we'll use that full depth. Cool. And I think we have one more detail or two left. Let's go and add this detail right here. We'll go and extrude that as well. And we're going to go and start that from this front surface, minus the depth. Nice. That looks quite good. I'm pretty happy with that. And, oh, eyebrows. We forgot the eyebrows. Now, in this case, maybe I'm just going to go back and grab one of these features that I've already used, and I'll just say add that profile to the feature that I already have. Either way is perfectly fine. So now I have that eyebrow as well. That's looking good. Now we do the same thing for the nose. So we'll just go and grab the mouth region, and we'll also grab the nose, like nostrils. We'll extrude those. And we're going to do that also from this profile plane, and the depth is going to be minus our depth. Looking great. Cool. Now, we didn't add any fillets yet. We might want to do that too. So we can go and add our fillets. And I guess question for you, CJ, are you actually going to route these fillets, or is this going to be hand done with a hand router?
Well, I'd like to do some with the CNC router, but probably going to have to leave some of them up to the hand router.
Okay, so let's model them all so that you have the, well, I mean, you'd have the opportunity regardless, but let's make sure to model them. Is there a particular radius I should use for this? 1/8 inch maybe, something like that?
Yeah, 1/8 inch would be fine.
All right, cool. So let's go and use 1/8 inch. That looks really good. And yeah, I'm pretty happy with that. We'll go and activate the face as well, and we'll do the same thing. We'll go and add our fillet. Now keep in mind that instead of filleting the entire face, I'm actually filleting specific edges because if I fillet this edge that's between these two parts, you're going to end up with a weird like scalloping effect, kind of like this between those two parts. So instead, I'm going to be a little bit more precise in how I pick them. And you'll notice here that I have this cutout for this like ear detail, and so I have to go and pick these two edges instead of one. So what I might want to do is instead go back in time, right? I have this timeline and I could go back in time whenever I want, like here, before I have those cutouts, and then I can go and add my fillets. So I'll go and grab this one edge, this one, and that one, and we'll go with that 1/8 inch. Nice. And now when I go forward in time, it'll go and actually execute those commands that were temporarily paused, and this is actually looking great. Only thing I'm noticing though is that this fillet kind of gets butchered over here. So maybe I want to go back and edit my feature for that fillet and get rid of just this one region right there and then make that fillet after the fact. Right? So the order that you go and create these features does matter. That's a great example. That's looking pretty good. And let's go and activate our assembly. So far, what do we have? We have the bottom piece, we have the two sides, we have the front. We didn't create the back yet. Let's go and mirror these front faces together and see where we're at. So we're going to go and activate the face yet again. We'll go and say create a mirror command. We'll mirror the entire body of this face, and we can mirror it across this mirror plane right there. Right now, those are going to be two separate bodies. So let's combine them. Combine tool, combine the left and the right, join them together, and now I have a single face that's symmetric. Perfect. Let's do the same thing with the nose and mouth, and we're going to go and do the same thing. So create our mirror. We're going to mirror this component across this face right there. We're going to combine this together, and that's looking great too. Activate the assembly, and now we're talking. We forgot some fillets on this front piece. We can go and activate that as well. Go and add our fillet. We'll go and pick all of these edges that we want to fillet, and the back as well, of course. That's looking pretty good, and that 1/8 inch I think is great. This is another opportunity to make one of those parameters. So let's go back to that parameter table, and we're going to call this my standard edge fillet, something like that. And we'll call this 1/8 of an inch. And now when I go back and I edit this feature, I'll just go and type that in here. So fillet, and now we have two options. We'll just go with a standard edge fillet and hit OK. That looks great. What I might also want to do is activate this back piece. Activate the back, pick that same sketch that we used from earlier. In this case, it's this one right over here. We'll go and select this region, and this time we're going to go and extrude that from this surface. We could pick any of these faces we want, but the thickness itself is going to be from that parameter table, just like that, and it's looking really good. I'll also go and add the fillets to this as well, and to make my life easier, this time I'll just go and pick the faces, and I think I misselected. Let's try that again. I want to pick this entire face, and we'll go with our fillet value. Standard edge fillet. Looking great. So let's go and activate our assembly yet again. And you'll notice I'm going back and forth between components and assembly, this component and this other component and back in this one. And it might seem like a jumbled mess, right? Because I'm being a little disorganized, and that's okay. I'm actually trying to show you that you can be disorganized and it's not really going to be a problem. You can always reorder your features later so that you're doing everything for this front face or doing everything for the nose and then moving on to the rest, or you could be a little bit more disorganized, and that's fine too, right? Remember that when you activate a component, instead of showing you all of the features, it will go and filter down to whatever features are specific to that component. Help you organize yourself, even if you don't help yourself organize yourself. So that's just something to point out. Now, we only have two things left before CJ. I'm going to ask you to take over. And those two things are going to be to fix the side profile of this particular flower box area and add the tail. And the tail has some detail in it that's important. I'm going to leave that for last. So let's go and do all of this. I'm going to go and select, let's say, this side. And we're going to go and activate it. That's actually this one over here. That's fine. We'll create a quick sketch. And all I'm going to do at this point is I'm going to project the geometry from this component. So I have all of it. By the way, if I don't want to see everything else, I could just say let's isolate it, make my life easier. And now I'm going to go and make an arc so that this is going to look a little bit nicer. That looks great. We'll go and apply some tangency and also make some symmetry. And I could even specify the exact amount of like, of like dip, so to speak, to my arc. Maybe that's going to be an inch. And we'll go and take these regions right here and we'll extrude cut them so that this is going to look a little bit better. And I like to just go all the way through. Nice. Let's go and take a look at that within everything else. Oh, that looks great. Let's go and fillet maybe this edge and that edge, and probably nothing else. Let's go and add that standard edge fillet. That's looking really good. And we'll go back to that assembly and see where we're at. So at this point, I think everything is looking pretty good with the exception of the tail, which we haven't done at all. So let's go and activate our tail and let's sketch what we want this tail to look like. So I'll go and create a sketch on that surface. I'll turn on my canvas and we'll look at that rear view. And here you could see that tail. So let's go and start to draw it. Well, we have a straight line here and we'll go and draw a straight line like that. We have what looks like a straight line kind of over here as well. So I'll go and draw some of that. I have what looks like an arc over there. So let's go and draw that. And I can go and mess with this until I'm happy. Actually, it looks pretty good. We'll also go and draw another line on this side, something like this. I do want them to be parallel to each other. And let's go and pick a dimension between them as well. Maybe, yeah, zero point 0.6 I think will be good. And actually, no, I was pretty happy with that. Zero point 0.7 is perfect. Let's go with that. So now we're going to go and add a couple more arcs. Let's say from here to here will be an arc. I like having smoothness, so we'll go and add our tangency as well. That looks pretty good. My shape got warped a little bit, so let's go and move that. And, oh, that looks way better. And I'll go and move this as well. Oh, extra line, we'll get rid of that too. Perfect. Let's go and add another line over here. We'll go add our additional arcs, something like this, something like this. Nope, I think I might have gotten something wrong. No, I think there we go. As long as I add a fillet over here, I think we're going to be fine. That looks great. So let's say for a moment, I'm pretty happy with this. We want to go and take this and turn this into 3D. So just like before, we're going to go and extrude this. Right, pretty simple, but I want to have a nice complex surface so that this is going to look really good. So let's go and do that. First thing I'm going to do is just extrude this thing. So let's give this the same thickness that we did for everything else. And that's what it looks like, right? Is this the nicest tail you've ever seen, CJ?
It looks pretty good to me.
Pretty good, but do we
Yeah.
want to do our like big fillet on the back?
Yes, please do it.
Okay, so there are a lot of ways you could do this. Probably the go-to for most people is to go and use the standard fillet command. And when you start to drag this, you're going to see that at some point it's going to fail. And it's going to fail like basically when the fillet on one side starts to cross over the other fillet. What you really want here is what's called a full round fillet. And we don't have full round fillets in Fusion 360 yet. So here's another approach you could use. And this approach is a little bit more advanced, but I think it's helpful. And it's surface modeling. So what I'm going to do here is instead of thickening this all the way, instead we're going to thicken this a very small amount, like maybe 50 thousandths of an inch, really thin. And what I'm going to do is I'm going to switch over to the surface modeling tab. I'm going to select this face and I'm going to delete it. So now I don't have a solid thing. I have a surface body. But what I could use is a tool like the patch command. And I could select this loop and it's going to go and patch it. But by default, it's going to use what are called connected tangencies. So it's just going to connect everything together. But I can switch this. First, let's group it together. So I could change this just once. And I'm going to change this to tangency. And now we start to get a much more interesting shape. That looks pretty good. Let's actually see what we get with the curvature option. That looks better, way better actually. And I'm pretty happy with that, and so I'll go and say okay. But at this point, I still have a surface. In fact, I have two surfaces. I have the body that we started with at the base, and then this top. So what I want to do is I want to stitch them together to make a watertight closed surface, and then Fusion will automatically go and turn that into a solid. So I can go and select this base and then this top area and hit OK. And voila, I now have my solid body. So that's fantastic. I'm pretty happy with that. Now, so far, this has taken me a lot longer than I expected, right? So I wanted to show you guys how you could also go and render this and apply your colors and everything else, but this is gonna already be quite a long live stream. So I think what we're gonna do at this point is just check that everything is correct, right? The shape is actually looking really good. I'm pretty happy with it. I might want to make these sidewalls a little bit taller actually. So all I have to do is go back into the sketch and drag this up a little bit, hit finish, and my 3D model updates. Oh, and that looks way better. Oh, way, way better. So now all I'd have to do is apply my colors, and I'd be pretty happy with it. But you don't need colors to be applied for you to go and machine this, do you, CJ?
Nope, but I have a model that is ready to go, and I can spend some time going over the toolpaths without going too far over our live stream time.
Perfect. So I saved this design. I said it's ready for CJ. I go into my project itself in my data panel, and you'll notice that under people, CJ.Abraham, he's already been added, right? He's already part of the project. If I didn't have him as part of this, I just type in his email address, hit invite, and then he's going to be invited to the project. And now when he logs into his Fusion account, he's going to have access to my files, and he can create all the toolpaths he'd like. So let's go and do one last thing before CJ takes over. I'm going to go into my comments tab right here in Fusion. This is a collaboration tool that I think is really handy. And I could type in the @ symbol and then CJ's name. His name pops up automatically because he's already part of the project. And I'm going to say ready for tool path magic.
Awesome.
So I post this. CJ, you're going to get an email automatically telling you that now you're ready for toolpaths, and then you can go in and start your toolpathing. So I just want to say thank you so much for doing this for me. By the way, I have quite a few mothers in my life. I have my mother. I have my mother's mother, my father's mother, my grandparents, right? Both sets. And then my wife, and we have our own kid, so our own child. So I have 4 mothers in my life. I was hoping you could make 4 of these for me if that's okay.
Yeah, we'll make it happen.
All right, cool. Thank you. All right, so I'm going to now switch it over to you. Hold on just a moment while I pull this up. There we are. With one exception, nope, we're good. Thank you, CJ. Take it away.
Awesome. So here is our cow. And my preference for making manufacturing documents is to create a new document. We have all of the design features in here, all the sketches and stuff, and I don't like to dirty that up with all the manufacturing stuff I'm going to be doing. So the first thing I do is I go to the create menu and select derive. And what this does, this allows me to select all of the objects in the feature tree that I want to put into another document. And it'll maintain that reference. So when I make changes in the original design, those will be reflected in this other document I'm sending all the objects to. So from here, I will select all of the components. So I click the first one. I'm holding shift to click on the last one. That selects all of the objects in between. And you can see all of the components have been shown in this menu. That's everything that's going to be transitioned over. Now, I've already made the document, and so I don't actually need to make a new one. But if I did, I could either create a new design entirely, which would create a brand new document, put all of these components in there. Or if I had already made a blank document or I know the target document I want to use, I could say add to existing design. Okay. And again, I don't need to do that right now. So I'm going to cancel this dialog and instead open the document where I perform the derive. And you'll see I've nested the components in here already manually. But what it would look like is the cow comes in here at 90 degrees because I have my Z up is default. But then all of these components are floating in space right now. And so I'd like to arrange these so that I can put them in a sheet of wood or MDF or whatever I want to cut them out of and cut them on a router. Now, we do have some tools that are going to come out soon regarding automatic nesting, but for now, I am manually nesting these by using joints. So all I'm doing is for each component, I know that I'm going quick with this, but I selected a joint origin on the component and I selected the origin of the document itself as the other target. And then all of these components are offset from the origin. So I've opened up, for example, the joint that is controlling the position of the face. It is offset 12.5 inches to the right and 5 inches in Y. And that's how I did each one of those. So again, this is a manual nest. Maybe it's not optimal, but it works for what I need. Okay. Now that all the documents all the components have been placed, I can go over to the manufacturer workspace and you'll see I have a setup where all of my toolpaths are currently invalid because I was moving stuff around. But what I will do is I will create a fresh setup to demonstrate how to create one. And I will go through each of these toolpaths and why I did what I did. So first step in creating a setup is to open the dialog. And I need to select all of the models in this document here. So I could select them one by one. Alternatively, I have the top level component available in here in the feature tree. So I can just click on that and it selects everything automatically. For my stock settings, I want to use relative size box. And the reason I wanted to do that is because as I'm moving the parts around, the stock model will get bigger or smaller depending on the needs. So I'll say around all the parts, I want at least 1/8 of an inch. Top offset, also 1/8. Bottom offset, also 1/8. So we've said that the part is 3/4 of an inch thick. 1/8 on the bottom and 1/8 on top will make this 1 inch thick, almost exactly. We have this other setting here, round up to nearest. So you notice that the numbers that are in here are not exact numbers, but if you type in round to nearest 1/8, it'll round the stock size up to nearest 1/8 for all the sizes there. That's pretty convenient. Okay, as far as the work offset location goes, I want that to be in the bottom left-hand corner of the stock. That's how I like to set up routers. So for the orientation, I already have stock box point selected. I'm going to select the box point down here. Okay. The orientation XYZ, I like that orientation right now. But if I were going to change it, I could click on this drop down, select which one I want. And with that, we have the model selected, we have the stock defined, and we have our coordinate system location. That's all we need for the setup. So we'll click OK. And we're ready to lay down some toolpaths. So the first one that we're going to talk about is the face toolpath. And that's what the finished face toolpath looks like. I'm going to copy this down into this operation so we can talk about the selections I made. I'm going to right click and edit that to open it up. And here's what we've got. I have a 1-inch face mill. I didn't have any particular face mills that I wanted to use off the top of my head, so I just assumed that a 1-inch face mill for routing the top of wood would be fine. Okay, didn't need to make any geometry selections. It defaults to the bounding box of the stock. The heights default to all the correct heights that I need, so it's from stock top to model top. That makes sense. Pass direction is both ways, which is fine. You could select either all climb or all conventional. And all of the linking parameters, the defaults I'm satisfied with. So when I click OK, that is the facing toolpath that results. The next thing I want to do, now that the top has been faced off even across all the parts, is do contours around all of the parts so that I leave a little bit of material on the bottom. I'm assuming that I've either secured this with a vacuum plate or maybe double-sided tape. So I want to leave the material intact on the bottom with a thin layer that's holding all the parts on, but all the material surrounding the parts, I want to slot. So I'm going to do that with a 2D contour. And I'm going to step through some of the selections here and generate toolpaths so you can see as I change each setting what the result is. So first I'm going to select a tool. I'm going to use this 1/4-inch flat end mill. For the geometry, I'm going to select all the outer contours of the parts. Note that some of them have fillets on the bottom, so you want to make sure that you select the outermost edge. In the case of these side panels, it's created an open contour. I want a closed contour. So I'm going to select this one more time, select closed contour from the little widget here. And I'm going to make sure that it goes up to the top of that fillet. Now that I've made that selection, I'll click the green checkbox to accept. I'll do the same thing for this other side panel here. So click once, click twice, change to closed contour, and make sure it's following the correct path. Now it is. Get all the other contours that I want here. Okay, that's all the parts. So if I just clicked OK now, this is the toolpath that I get. It just does one pass around each part, which is not necessarily what I want. It's going to plunge into the material. It's going to try and slot it to full depth, probably going to break the tool. So let's make some changes here. The first thing that I want to do is instead of plunging straight into the material, I actually want to start from the top and ramp my way in. To do that, I'm going to go to the linking tab. I'm going to disable lead in and lead out, and I'm going to turn on the ramp checkbox. This is how we get to do that even spiral ramp along the profile. Maximum ramp step down. So think of this as like a thread is a good example of this, where this is the spacing. So when the tool comes back around, this is the maximum step down that the tool experiences as it comes to the same point again. So if I type in 50 thousandths, the tool is never going to be taking a bite more than 50 thousandths deep. Okay, ramp clearance. This is just from the top of the part. So now if I click OK, we see a lot of red here, but the red is okay. The red just means that it's a ramp strategy. Okay, so if I zoom in on the entry of this point here, you can see it plunges almost to the top of the material, and then it starts spiraling its way down the profile of the part. It's exactly what we want. Okay, any questions about that so far? I see a couple of comments. Nope. Okay.
CJ,
So
I'll
moving
just
on from
I'll
that.
just
Oh,
say that I'm super jealous of your cam skills here.
oh, thank you. I've been doing it a while. All right. So let's do a little bit of simulation so we can see our progress so far. So there's the facing, and you can see there's the profiling of each part. I'm going to speed this up quite a bit. But you can see it just leaves a slot big enough for us to access the part, maybe break off the material on the bottom, but it's not roughing away all of the material that's there. That would just take way too much time. Okay. So the next thing we want to do is do those pockets, engrave out those pockets for the mouth and nose and the eyes and all the other features that we did before. So I'm going to separate those out too. I'm going to do one pocket for the mouth and nose and another pocket for the other features. So I'll select 2D pocket. Operation opens up. I'll open up the tool library to select my next tool. In this case, a 3/16 flat end mill. Okay, it's loaded my preset. This preset dropdown is a new feature with the new tool library, and I highly recommend that the CAM users use it. It encapsulates cutting data for tools and allows you to store RPMs, feed rates, step downs, and step overs for all your tools. And you can store multiple per tool. It's really great. So for geometry, select the face of each pocket there. That's all we really need to generate that tool path. Okay, and you can see it ramps in. It ramps in pretty high off the part, and that's because it's defaulting from the stock top, which is material that we had removed already. So if we wanted that ramp to start a little lower, I could go to the heights tab, and instead of the top height being stock top, I'll change that to model top. One additional parameter that controls that height is the ramp clearance height on the linking tab. So I could change it to something really small, like 10 thousandths instead of 100 thousandths. And that's how we get that ramp to be so low. Notice it's almost gone now, but it does in fact start off the top of the part. Okay, so now I'd like to do that same thing for all the features on the face. Instead of creating a brand new operation, I'm going to hit Control D on my keyboard, and that duplicates the operation. That's also available from the context menu. If I right click and choose duplicate, that's the exact same It's exact same action as Control D. And I'll edit this toolpath and I will just change the selections. So when I go to the geometry tab, I can click this X that clears all the selections. I'll then select all of these faces here, right? So it recognizes both open and closed pockets. And I'm going to skip the eyes because I'm going to use the 3D pocket strategy to do the eyes. And you'll see why in a second. But I'll click OK. And there's our toolpath to do those features. And now I'm going to use 3D Pocket. 3D Pocket is typically a roughing strategy, but because this is wood and we're not too worried about tolerances, I think the 3D Pocket strategy is perfect for this. In the Geometry tab, all I need to do is select the area where I want to remove material. So machining boundary, I'll choose selection. The boundary will be the inside of the ovals of those eyes. For the top height, I don't need stock top. I want model top. And I'll click OK. And that gives me a really quick strategy to rough out just those areas there because it gets the multiple steps, it gets the multiple contours of the features there. I think that works nicely. Okay, let's do another simulation just to see where we're at. So I'll right click the setup, click simulate, click play, and drag the slider all the way to the right to speed this up. I don't see any collisions on the timeline at the bottom, so that means our tools are long enough. We're not colliding with any holders, so that's good. And that is what the features look like so far. I'm pretty satisfied with that. And you'll notice I'm going to the model bottom, but not to the stock bottom. And so it's leaving a little bit of material. I've zoomed in here so you could see that.
And
We can
CJ,
control. Yep,
quick question for you. So right now the colorization is by operation, right? So each of these colors represents a different operation. What are
correct.
your thoughts on the colorization for like how much material is still left? Do you use that option at all?
I do. I use it typically on more complex features like for molds and things like that. But let's go ahead and take a look at it. So under standard mode, the colorization, you have an option for comparison. And what this does is it colorizes the areas where there is material left over, where material has been adequately removed. So now you're just showing the part, or also areas where you've removed too much material. Those would show up as red. So if I zoom in a little bit here, you can see the bluish areas are areas where there's still material. The green areas are where we have machined up to the part, and there are no red areas because I haven't over machined any areas.
Cool. Cool. Red meaning like gouges, right?
Correct.
Excellent.
Change that back over to operation, and we'll close the simulation. And what do we want to do next? Um, Looks like in the toolpath I did before, we have this boring operation to do these holes. So let's check that out. If I click on one of these holes, I want to know how big it is. In the bottom right-hand corner, it might be really small. It might not even show up on my Zoom meeting right now. But if I click on that face, it tells me the radius of that arc down here. I don't know if everyone could see that. Maybe, maybe not. But it's telling me that the radius is a 1/4 inch. So that hole is a 1/2 inch in diameter. So what I'll do is I'll use a 2D bore toolpath with a 1/4 inch end mill. Okay, select that tool. And I'm going to select one face, and you'll see that instantly creates a preview of a helical toolpath that cuts that hole. And I could either continue selecting the other holes, or I could turn on this checkbox, select same diameter, finds all the same diameter holes. So that's a nice parametric way of finding all the same features. And I'm satisfied with that, so I'll click OK. And finally, we will do, well, not finally. Next we'll do the tail here. It's the last part that hasn't been touched, which is why I said finally, but we want to rough and finish the tail with the 3D surfacing there. And that
You
last thing we'll do is include all the radii that we put on the ends.
you saved the best for last, didn't you?
I sure did.
You know, we have a lot of customers that are using like 2.5 axis milling on a regular basis, like everything else you showed. And we get a lot of questions about 3 axis, so this is going to be perfect.
Awesome. All right. So For roughing this out, first let's take a look at the simulation results so we know what we're roughing. So to skip to the end, I've got this button, go to end of toolpath. So I'll click that and I'll give it a second here to calculate. Okay, goes through all that. Okay, so this is what we need to rough. We have the tail slotted out around its profile, but we still need to rough everything that's on top of there before we can apply a finishing toolpath. We could use 3D Adaptive or 3D Pocket. And this is a case where I'm going to use 3D Pocket. 3D Adaptive is good for when you have a lot of access to a part because it wants to cut with the full flute length, and the entry and exits for that kind of want some space between it and the material. And 3D Pocket is better if you're going to be doing more slotting with your tool and taking shallower depths of cut. So let's do that. I'll create a new pocket clearing strategy. I'd like to do this with the 3/8 or 3/16 flat end mill we were using before. And note that I have a 3/16 bull nose end mill for the finishing. Okay, so I've got this flat end mill. For the geometry, what I want to do is consider the silhouette of just this part. And what'll happen is if I choose silhouette right now, I have every one of these bodies chosen in the setup. So it's really doing the silhouette of all of these parts. What I can do is I can turn on this model checkbox, and this is a model override. And by unchecking include setup model, now whatever I select is the only thing that this toolpath will consider. So I'm going to select the body of this tail, right? So now I have a boundary that is a silhouette, and I'm only considering the body of this tail. For the heights, we're going to model bottom. That is perfectly fine. Passes, I want a maximum roughing step down of, this is a default for 1 millimeter, and that happens to be in inches. Let's change this to 25 thousandths. And 20 thousandths of radial and axial stock delete is likely fine. So we'll click OK here. And here's our result. This isn't quite what I wanted. It's not going over the edges of the part, and we can fix that. So I'm going to go back into Edit, look at the Geometry tab, and you'll see that our machine boundary is silhouette, but the tool containment is tool center on boundary. That's why the tool wasn't able to go outside the profile of the part there. So I'll change tool center to tool outside. And that's exactly what I want. It looks like a busy toolpath, but that's because it's entering uh, using a ramp on each level. And it has some linking in between there. But that is a perfectly fine roughing strategy. And for the finishing strategy, I'll use 3D scallop, choose that bull nose end mill because it has a corner radius that is good for doing 3D geometry. I could use a ball end mill as well. That would be perfectly acceptable. Okay. And I'll make very similar selections. So for the geometry, this time, yeah, let's do silhouette. The model override is going to be just this body. Tool outside boundary, but I don't want it to go so far outside the boundary that it starts dipping over. So I'm going to make sure that's at the model bottom. That's fine. And passes. I want the step over to be, let's say 10 thousandths. It's going to be a really fine step over. Let's see what we get. Oh, that's going to be a really long calculation time. I have to wait more than 10 seconds. So to me, that's an eternity. Okay. Yeah, that's a really fine toolpath there. Looks pretty good to me. It's the fanciest tail you're ever going to see. All right. And the last thing we're going to do for these is include the radius on one side. Obviously, I can't get the radii that are on the bottom of these parts, but we could do that with a hand router later. Jason, do you have any opposition to that?
No, I've been doing hand routing forever, so the fact that you could do even half of this with the CNC is fantastic.
Cool. So to do that, I'll use a 2D contour, and I will select a corner radius tool, right? So it has a little corner radius that it cuts on the bottom there. And I'll go ahead and select all of the edges that have radii on them. Oh, this is it's not quite what I wanted there. Let's try that one more time. Okay, geometry. Okay, there we go. And I'm just selecting the ones that I have access to. So we have those edges there. If I turn these guys around, there's a couple on the top of the sides. Okay. And
Then mouth
don't
and
forget the
nose as
mouth.
well.
Yep.
Perfect.
Okay. Looks good to me. Click OK. And let's simulate this one final time before we go out to our imaginary machine and cut this.
Yeah, normally I would say, the Shopbot that we have over at Pier 9 would be perfect for this. It's an 8 foot by 4 foot table, if I remember right. It would be
Yep.
absolutely perfect for this. Right now, we're all stuck at home, kind of, so we're just simulating this. But we forgot one thing that's pretty important, and maybe we'll wait till after you've simulated this entire set. But if you remember at the beginning, I'm going to try to give these gifts to my mother, my grandparents, and my wife. So
Oh, that's
I
right.
alone need 4 of these. You might want some as well. So what's the best way to take all of these machining strategies that you just made and make like multiple?
Yeah, that's easy. So let's do that as soon as this toolpath finishes simulating here. There's our fillets. So you can see it's applying fillets to
Oh,
all of the
nice.
edges that we chose. Very nice. Okay. So how do we pattern this? So if I zoom out a little bit here, what I'll do is I'll take all of these operations. I'm shift selecting them, right? So I click the first one, held shift, click the last one, selects all of them. I will right click on any of the toolpaths highlighted, and I will say add to new pattern. And from here, I can define, just like we have modeling patterns, you can pattern toolpaths in the same way. So first I need a direction. So I'll select the bottom edge of that bottom plate there. And the parts won't pattern with them, but you will see the toolpaths update here. So for pattern one spacing, let's put in 12 inches here just so we get, looks like we need a little more. Cool. Right. So you can see there's one pattern instance. Let's add a little bit more. Let's make it 26 just to get some space in between. Okay. And that's 2 instances. And all I need to do is add however many instances I want that would fit on the table. So this is likely a huge router at this point. But now
Yeah,
I got 4 instances. I also could have done 2 and 2. That would have worked.
that makes
And
sense.
we have some operation ordering settings here. So right now, like if I chose preserve order, it would do all the operations on the first instance, then all the operations on the second, right? It would face, contour, do everything. Alternatively, you could say order by operation. So it'll face all four, then contour all four, and then pocket all four. You could also order by tool. And what this does is, as long as it's using the same tool, it will stay on that instance before moving on to the next. So looking at our list of operations here, we have a face toolpath. So it'll face, 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 face. And then we have the contours. It'll do all the contours. And then our next operation, so these two pockets and the 3D pocket, those all use tool number 3. So we'll do the operations for tool number 3 on instance 1, then instance 2, then instance 3, before moving on to the next operation that uses a different tool.
So do you find yourself mostly ordering by operation or ordering like, using the entire instance and then moving on to the next and being okay with the tool changes?
I typically order by tool. It results in the least number of tool changes and the least amount of movement, which means it's the most optimized for time.
Hmm.
But there are definitely reasons you would want to use the other methods. That could be, for more production environments, you might care about tool wear and the progress of tool wear on different parts and things like that. So you might not be able to use um, the optimal ordering to save time. You might need to use ordering that is better for tool wear, things like
That
that.
makes sense. And do you end up with a different strategy when you're making the very first of something versus like you've already made one, you know the toolpaths work, and now you want to make 50 of them?
It depends. It depends what your goals are. So most of the time, like let's take prototyping versus production for machine parts. All of the time that you spend programming a part is typically in the first part, which is why prototypes are expensive. And then you could amortize all of the cost over the second and third and things like that. So if you start with a good program, all you need to do to make more good parts is press cycle start and keep going.
That makes
Uh,
sense.
Now, you might make other choices where if you know you're going to make 1,000, you might buy nice tools to make that 1,000. If you're going to make one, you're probably not going to spend a ton of money uh, investing in tooling just to make that one part, unless the part calls for it and you can charge your customer for that. But
That makes perfect sense. We had another question from the audience. So someone asked, his name is GN. Actually, it's he or she, I have no idea. GN asked, what do you do if you want to be able to, let's say, create those fillets on the backside in your CNC machine?
you have two options. One is that there does exist a tool that is an undercut radius tool. I believe Harvey Tool has some. That's just a brand I knew off the top of my head that might have them.
Hmm.
The alternative is that you have to refixture the part, flipped over, and cut it again.
Hmm.
Which I haven't prepared anything for that specifically,
That's
but
okay. And
yeah,
tell
I
me,
could go for hours about fixture design and how to hold it and how to locate it and things like that. But yes, you would flip the part over. You might cut out a silhouette and a fixture to hold it down. That would also help you locate it easily.
mhm.
And then you could cut the fillet on the other side using the same tool paths.
Oh, interesting. So I know on some of the fancier machines they have probes, right? So you could put your part down and probe it and be able to basically find the part in relation to the machining table. But if you don't have a probe, you're saying put a piece of wood down that you're going to sacrifice, cut out the profile of the shape of the part itself, but then you put the part itself in that profile and use that as the fixture to hold it in place exactly where you want it.
Yep.
Perfect. Very cool. Well, this is excellent. Anything else you're showing on the toolpathing side of things?
Nope. This is it.
All right, cool. Well,
Yeah.
then let's jump back to webcam for a second. Let's summarize what we did today. Well, hopefully, we made our mothers proud, the mothers in our lives. But the goal was to recreate something simple, right? Something like this cow planter, right? We designed it using canvases, designed it using multiple components. We did use some tricks like mirroring the component while you designed half of it. We also we're able, we didn't show it, but you can also, of course, render your picture, your model. You can add your color and the black versus the white on the cow, for example, things like that you saw on CJ's finished design. And then CJ went and took that, manually nested it, and then applied his toolpaths. He showed you the ins and outs of each of those toolpaths and how he used it. We had a couple of questions from the audience that we got to answer along the way as well. But long story short, CJ, when you're designing something like this for the programming, how long would it take you to program a part like this? Not
Ooh.
on a live stream, of course.
Not on a live stream. Well, I'm really particular with my toolpath, so I might spend more time than other people. But let's just say if I was in front of a machine that had all the tools, I could have a cow in an hour. How about that?
Nice. Yeah, and I spent about 55 minutes designing mine during the live stream. When I designed the first one before the live stream, I would say about 35 minutes, something like that. Put on your headphones, jam out to some good tunes, and just start making things. So it sounds like if you are able to do the design and the toolpathing yourself, something like an hour and a half total of design and programming time, and then it's just a question of how fast your router's actually going to go and make those parts for you. Right? So within a couple of hours, you can go and make incredible GIFs. Fusion 360, you probably already know this, everyone out there, but it's a professional CAD tool. It's used by a wide range of companies for all sorts of incredible products. But what good is a professional CAD tool if you can't also use it to make some people in your lives happy? Personal projects. And so this is a great example of a personal project. CJ, I'll speak on my behalf. I very much hope everyone out there enjoyed today's live stream. What do you think? You think they did?
I think it was fun. Yeah, had fun doing
Good.
this.
Well, thank you everyone out there, and don't forget, with Fusion 360, you can make anything. Have a great day, everyone, and good luck.